Compiler design, semantic analysis. Topics that we are going to discuss are semantic analysis, syntax-directed translations, syntax-directed definitions, and types of attributes. Semantic analysis is a phase of compiler design that takes input from syntax analysis and it performs certain kind of actions. It produces annotated parse tree as output. So in the input to a semantic analyzer is a syntax tree and the output that we are getting is annotated parse tree. In C, normally the semantic analyzer performs type checking and certain additional informations are added into the symbol table. Semantic analyzer performs some sort of activities during compile time and some sort of activities during runtime. What are the various activities a compiler performs during compile time? In C, variables are used like a equal to 5. When a variable is used, that variable has to be declared before, like int a, float a, char a. It checks whether the variable has declared before the usage, and it checks the type of parameters in the LHS and RHS in an assignment statement. Here the type of A is int and type of 5 is int. That means the type compatibility is correct. In another case, this function, the semantic analyzer checks the parameter type and number of arguments in case of function code. For example, some a comma b is a function call and it has two arguments a and b, and it expects the function definition to accept exactly two number of arguments having the same type of a and b. That is checked during the compile time. Now let us check what are the various runtime semantic comparisons the compiler performs. It performs an overflow in case of arithmetic operation, whether the addition of two numbers exceeds the bound, or it performs it compare while division with 0, it checks whether division by 0, or in case of array, it checks the array limits. In for loop, we are trying to enter elements from 0 to n and it checks whether the n is allowable. If n goes beyond the allowable range, it gives some errors. And in case of recursion, we have to clearly specify some terminating conditions. Otherwise, what happens? The recursion stack will expire. In case of memory allocations, in case of heap memory allocation, it checks whether the heap memory is sufficient. So in short, what these are the various semantic comparisons a compiler performs while executing a program. This makes clear using a sample of program. In this program code, we have to identify what are the actions semantic analyzer performs. Let's make it clear. In the case of static analysis, here int total a variable has used here, and it checks whether the variable is declared before. It is declared int total. And in case of here, it has a function sum of elements and it has passing two arguments array and name. In the function definition, it exactly accepts two parameters array and n, and both the type are same. Here what we can see, it is using a variable sum, it is pre-declared, and it is using an I that is pre-declared. Elements of array, this sum is an integer and this left hand side is an integer, and array of I is of course an integer, and it returns some value sum. It is same as that of expecting result total. These are the some semantic checks that performs during compile time. Now let us clear what are the various semantic analysis perform during compile runtime. Here, what is the maximum size of array? Size of array is 9, and its for loop it varies from 0 to 9. That means there is no issues with array out of bound. And in case there is no overflow in case of this addition. Now let's see what are the errors the semantic analyzer finds here. Here we are just using a variable total that is pre-declared. Is there any mistake? No. And in case of we are in this function sum of elements, it is passing one element and the function definition receiving two elements. Then there we got an error. What error we get here? Too few arguments into the function call. In case of here, the function call passes how many arguments? It passes 3 arguments. And in case of function definition, it accepts only 2 arguments. That means it gets an error too many arguments in the function call. So these are the various errors a semantic analyzer identifies. Now let's understand how the semantic analyzer performs these kind of activities. In semantic analyzer perform this kind of activities during a scheme or a method known as syntax directed translation. Syntax directed translation is used in semantic analyzer and it augments what are the various semantic actions that are to be done when a production is performed. For example, mainly this syntax directed translation, two concepts we have to clear, that is one is syntax directed definition, another one is translation scheme. In syntax directed definition, these are the two topics that we are going to discuss more deeply in the coming session. So as an introduction, what is syntax directed definition or SDD? That is SDD. SDD syntax directed definition builds the semantic grammar by attaching attributes to each variables and semantic action accordingly. In translation scheme also is similar to SDD and it specifies the order of execution of semantic actions. Now we'll discuss more clearly what is SDD. SDD associates two kind of things. One is attribute, another one is semantic action. Attribute is related with the grammar symbols, variables, and semantic rules are associated with productions. For example, we are assuming x is a grammar variable and a is an attribute of x. How we get the value of x? Value of a for that attribute x, that is x dot a. For example, production is e gives e1 plus d. All these attributes having one attribute value. For saving the value, we are using one attribute, that is val. A dot value is equal to a1 dot value plus d dot value. That this STD before we have seen till here. This is a context free grammar. Now in semantic analyzer, it augments some semantic action. To include this semantic action, it uses some attribute. This value is an attribute and this all together is a semantic action. This is grammar plus semantic action together gives SDD. How the attributes are evaluated in an SDD. For a given input x, we have to first construct the parse-tree. Then apply the semantic rules when and where we see the productions in the parse-tree. The output that we are obtained in the semantic analysis is annotated parse-tree or decorated parse-tree that contains, in the syntax tree, it contains additional attributes and its values. For example, a syntax-directed definition of a symbol desk calculator. Now let's understand what are the various operations this symbol desk calculator performs. Addition, subtraction, multiplication, division, division. And this grammar we have already learned in case of syntactic analysis. Now let's clear in STD what we have to add. We have to add some attributes and some semantic actions. Here in here we have added e dot value is equal to e1 dot value plus t dot value, and here what gets e dot value is exactly same as t dot value. Here this t dot value is equal to t1 dot value into f dot value. T gets its value from f, that is t dot value is equal to f dot value, and from where f gets value from either digit that or f gets value from expression, that is e dot value is will give pass into f dot value. Now we get an STD because we have context free grammar and we have actions. Let's construct an annotated parse tree for 3 into 5 plus 4n. What is this n means? N is some end marker. Like a dollar in the previous examples, here n is an end marker. Using this STD, but we have to perform the semantic analysis. For that, first of all, we have to construct the parse tree for 3 star 5 plus 4. For that, we have to select appropriate productions from this given grammar. We have to start from L gives E. This N is some end marker like our dollar in the previous examples. L gives E N. For this E, it takes a production E plus T. Don't confuse with E and E1. Both are same. To distinguish LHSE and RHSE, we have simply put this suffix 1. E gives E plus T, and this E gives T, and this T takes a production T star F, and from T we require digit, that is F. T gives F, F gives digit, here F gives digit, T gives F, F gives digit. That's it. We got a parse tree. Now we have to traverse like this, and we get digit dot lex value is equal to 3. Why we got 3? 3 is our input. But from where we get this lex value? Lex value we get from the lexical analysis. And now what we have to do? We have to traverse here. This t dot value is equal to f dot value, and here we have not seen the production here. We have seen till only the left part of this t. And here digit dot lex value is equal to 5, and here f dot value is equal to digit dot digit, and here t dot value is equal to f dot value, and here e dot value is equal to t dot value. Now we have traversed till here, and the digit gets its value 4, and continue traversing this, and this f gets its value 4. How f takes its value is equal to digit dot lex value, and we continue traversing here, and this fe gets its value from t, and continue traversing here. This l gets its value 19 and print the value 19. Now we have got the annotated parse tree for the input 3 star 5 plus 4. How initially we started from the parse tree, then traversed the parse tree performing the semantic actions. At the end we got an semantic syntax tree that is decorated with all the attribute, that is annotated. Now we are going to discuss about various types of attributes. STD associates attributes with its variables. There are two kinds of attributes. One is synthesized attribute, another one is inherited attribute. As the name indicates, synthesized attributes synthesize its values from its children. Consider this example: S gives AB. S is a parent and A and B are its children. S takes its values from its children A and B, then such attribute is synthesized to attribute. Consider this example here. E gives even plus t. E has an attribute value. It takes its values from E1 and T1, T, and so this val is a synthesized attribute. Now consider what is an inherited attribute. As the name indicates, inherited attribute inherits from its parent and siblings. Here example A gives B C D. Here C can inherit from A, B and D. Here C dot type inherited in is equal to A dot inherited and C dot type is equal to B dot type.